Hello there, and welcome to Sleepy Science Stories. Tonight, we are going somewhere dry. Somewhere very dry. We are going to a desert in the north of Mexico, where the sky is enormous, and the ground is flat and pale, and the silence is the kind of silence that has weight to it. The kind of silence that presses gently against your ears and makes you aware of your own heartbeat. This desert stretches across 3 Mexican states. Its name is the Chihuahuan Desert, and it is the largest hot desert in North America. It covers more than 360,000 square kilometers. It is home to hundreds of plant species found nowhere else on Earth, including cacti that turn a shade of deep purple during dry spells. It is home to the Bolson tortoise, a large and ancient reptile that has been here far longer than any human settlement. It is home to golden eagles, roadrunners, small lizards, and the kind of patient, sun-hardened life that only a desert can produce. And somewhere inside it, near a place called the Trino Vertex, where the borders of the states of Chihuahua, Durango, and Coahuila meet, there is a patch of desert about 50 kilometers across that people have been calling by a very unusual name for more than half a century. They call it La Zona del Silencio, the zone of silence. The name suggests something dramatic, and the stories attached to it are dramatic indeed. Radio signals that vanish without explanation, compass needles that spin in slow, confused circles when held near certain rocks, meteorites that fall here with what seems like impossible frequency, a missile fired from a base in the United States that went off course by hundreds of kilometers and crashed precisely into this place, as though drawn by something in the ground. Strange lights seen at night by ranchers who have no reason to invent such things, and 3 mysterious blonde strangers who appear at desert ranches asking only for water, speaking perfect Spanish, and then disappearing without footprints. Tonight, we are going to explore all of it, not with the goal of proving or disproving, but with the goal of understanding. Because the zone of silence is a place where real science, real geology, real physics, and real human psychology all intersect in a way that is more interesting than any simple answer could capture. We will talk about how radio waves work and what can stop them. We will talk about magnetite, the magnetic mineral that sits beneath the desert floor here in unusual quantities. We will talk about the ancient sea that once covered this land and what it left behind. We will talk about the meteorites and what it means for so many of them to have fallen in one place. We will talk about the missile and what actually happened. And we will sit with the harder question at the end. What is the difference between a mystery and a misunderstanding? And why do some places in the world attract both in equal measure? If you enjoy these sleepy science journeys, please consider liking or subscribing so other curious minds can find their way here. Every listener helps. But for now, let your body settle. Let the day dissolve, and let your mind drift toward a pale flat desert under a sky full of stars, where something in the ground has been asking questions that science is still learning to answer. Deserts are psychologically unusual environments. They are places where the sensory information that usually orients us, the sounds of water, the rustling of leaves, the calls of birds, the presence of other people, is reduced to almost nothing. In the Mapimi Basin, especially away from the few tracks that cross it, the silence is genuine. Not just the absence of radio signals, the absence of almost all ambient sound. Wind, your own footsteps on the dry soil, the occasional call of a bird far away. That silence is disorienting. It creates a heightened awareness. Every small sound becomes significant. Every change in the light, every strange shape of a rock, every spinning of a compass needle registers differently than it would in an environment full of other sensory information. The desert creates conditions in which the unusual appears more unusual, and the unusual appears more meaningful. This is why mysterious places tend to cluster in remote and inhospitable environments. Not because there is more mystery there, but because the sensory isolation creates conditions in which mystery feels more present. The zone of silence would be a very different kind of story if it were located in the middle of a city, surrounded by traffic and voices, and the constant background noise of human civilization. The same geology, the same compass anomalies, the same radio interference. But without the silence, it would not feel like the zone of silence. The silence is the real first mystery. The rest follows from it. The Chihuahuan Desert sits at altitude. Most of the Mapimi Basin floor is around 900 meters above sea level. The surrounding mountains are much higher. This elevation, combined with the extreme aridity, produces a quality of air that is unusually transparent. On a clear night in the zone of silence, with no lights for hundreds of kilometers in any direction, the sky is overwhelming. The Milky Way is not a suggestion. It is a structure. You can see its shape and depth with your naked eye. Astronomers consider this kind of sky darkness a scientific resource, as rare and worth protecting as any biological specimen. The desert preserves it by accident, through its remoteness and its poverty. The same qualities that made the missile recovery operation so remarkable when it happened, that there was no infrastructure here, no paved roads, no permanent residence within many kilometers. What was a disadvantage for human habitation is an advantage for any science that needs a dark sky or a pristine geological surface. Let your mind carry that image as we begin. A dark sky full of the same stars that made the iron in the ground below them, looking down on a pale desert that was once a seafloor, where a compass needle is slowly swinging away from north. Let us begin. Before we can understand what makes the zone of silence unusual, we need to understand something most of us take for granted every single day. We need to understand radio waves. Right now, passing through your body, through the walls of the room you are in, through the ground beneath you and the sky above you, there are radio waves. Dozens of them, hundreds of them. Some carrying music from stations broadcasting across your city. Some carrying navigation signals from satellites orbiting 20,000 kilometers above the Earth. Some carrying the encrypted communications of aircraft flying at high altitude. Some coming from the sun, from distant stars, from sources so far away that the waves have been traveling since before the Earth existed. You do not feel them. You cannot see them. But they are real, and they pass through you constantly, every moment of every day, without you ever knowing. A radio wave is a form of electromagnetic radiation. That means it is the same fundamental thing as visible light, as ultraviolet radiation from the sun, as the infrared heat you feel when you hold your hand near a warm stove. All of these things, light, heat, radio, are electromagnetic waves. They differ only in their wavelength and frequency. Radio waves have the longest wavelengths in the electromagnetic spectrum. A single radio wave from a standard AM broadcast station might be 300 meters long, from one peak to the next. That is 3 football fields laid end to end. An FM radio wave is shorter, about 3 meters. The waves used by cellular phones are even shorter, measured in centimeters. All of them, regardless of length, travel through empty space at the speed of light. In 1 second, a radio wave can cross a distance of nearly 300,000 kilometers. Because of their long wavelengths, radio waves have an unusual ability. They can pass through most solid objects. They can pass through walls. They can pass through trees. They can pass through the human body. They bend around buildings and hills, curving their path the way water curves around a stone. This is why you can listen to a radio broadcast inside a building, or in a valley surrounded by hills, or in a city full of concrete and steel. The waves find a way through. There are things that stop radio waves. Dense metal objects can reflect them. Certain materials absorb them. The ionosphere, the electrically charged layer of the upper atmosphere, reflects some frequencies back toward Earth and allows others to pass through into space. Water conducts electricity and absorbs radio energy, which is why radio signals weaken when they travel through very wet soil. And certain minerals are particularly good at interfering with electromagnetic signals. Iron is one of them. Iron is a conductor of electricity. When a radio wave passes through or near a body of iron-rich material, the wave can induce small currents in the iron, which absorbs some of the wave's energy. The signal weakens. If the iron-rich material is dense enough and distributed widely enough, a signal can be weakened to the point where a receiver cannot detect it. The radio goes silent. The signal is not destroyed. It is absorbed and scattered, converted into tiny amounts of heat. The most magnetic iron mineral that occurs naturally in the Earth's crust has a name. It is called magnetite, and the ground beneath the zone of silence contains a great deal of it. This is the starting point of the science behind the zone. Not mystery, not the paranormal, not interference from another dimension. Iron mineral in the ground, absorbing radio energy the way a sponge absorbs water. But the story does not end there, because the question of where all that magnetite came from and why it is distributed the way it is in this particular stretch of desert leads somewhere genuinely fascinating. It leads into deep time, into an ancient ocean, into a rain of stones from space, and into one of the most unusual geological histories of any place on the surface of this planet. The electromagnetic spectrum is vast. Radio waves occupy the lowest frequency, longest wavelength end of it. But within the category of radio waves, there is enormous variety. The waves used for AM broadcast radio have wavelengths of hundreds of meters. The waves used for FM are a few meters. The waves used for cellular communication are measured in centimeters. The waves used for satellite navigation are even shorter. Different wavelengths interact differently with the physical environment. Very long wavelengths can travel thousands of kilometers by bouncing between the Earth's surface and the ionosphere. Medium wavelengths travel by following the curve of the Earth's surface for hundreds of kilometers. Short wavelengths travel in straight lines and require a clear path between transmitter and receiver. The behavior of radio signals in the zone of silence depends partly on which frequency you are using. A very long wave signal might show little effect at all. A medium frequency signal traveling through the mineralogy of the Mapimi Basin might show significant attenuation and distortion. A high frequency, short-range signal might cut out entirely when passing over a dense pocket of magnetite near the surface. This is why reports of radio interference in the zone are inconsistent. Different radios, at different frequencies, in different locations, over different parts of the basin geology, will produce different results. Some radios work. Some do not. Some work in one spot and fall silent 20 meters away. This is exactly what you would expect from a variable geological landscape, not from a uniform mystical force. Let your mind rest in that image for a moment. The radio signal traveling at the speed of light through open air, carrying music or voices or navigation data, and then encountering something in the ground that reaches up through the soil and quietly drains its energy away. Not malevolent, not intelligent, just chemistry, just physics, just the silent work of iron and electromagnetic induction, doing what they have always done, in a desert where no one was listening, for decades before anyone thought to notice. To understand what is in the ground beneath the zone of silence, you have to go back very far in time. Not thousands of years, not millions. Hundreds of millions. Hundreds of millions, roughly 100 million years ago, during the geological period called the Cretaceous. The area that is now northern Mexico did not look anything like it does today. There were no deserts here. There were no flat plains baking under a dry sky. This entire region was covered by a shallow, warm, tropical sea. Scientists call it the Tethys Sea, or the Sea of Tethys. It stretched across a vast area of what is now North America, connecting the Gulf of Mexico with a body of water to the north. It was warm, rich in life, and full of the kinds of marine organisms that build their shells from calcium carbonate. When those organisms died, their shells sank to the seafloor and accumulated in layers over millions of years. The weight of the sediment above compressed the layers below into rock. Calcium carbonate sediment becomes limestone, and so the floor of this ancient sea became, over immense stretches of time, a thick platform of limestone and chalky sedimentary rock. The sea eventually retreated. The land rose. The climate changed. What had been a seafloor became a desert basin. And today, when you walk across the surface of the Zone of Silence, you are walking across the compressed remains of that ancient tropical ocean floor. The rocks beneath your feet contain fossils of marine organisms that have not lived in any ocean for 65 million years. This is why scientists at the Mexican Research Station, built here in the late 1970s, named the area the Mar de Tethys, the Sea of Tethys, a memory of what was here before. The ancient seabed geology matters for several reasons. The first is mineral content. Sedimentary rocks laid down in ancient seas often contain elevated concentrations of specific minerals, depending on the chemistry of the seawater and the organisms that lived in it. The Mapimi Basin, which is the geological depression in which the Zone of Silence sits, contains sedimentary layers rich in several significant minerals. Magnetite, the magnetic iron oxide mineral we discussed earlier, is one of them. Uranium, a radioactive heavy metal that also has electromagnetic properties, is another. The presence of these minerals in the ground is not mysterious. It is a straightforward consequence of the geological history of the area. The second reason the geology matters is structural. The Mapimi Basin is a closed drainage basin, which means it does not drain into any river or ocean. Water that falls here stays here until it evaporates. This has allowed minerals eroded from the surrounding mountain ranges to accumulate in the basin floor over millions of years. The concentrations of minerals in the basin sediments are therefore higher than in most surrounding areas. The basin acts as a trap for material that would elsewhere be washed away. The third reason is related to the meteorites, which we will discuss shortly. But it is worth noting here that the flat, light-colored, sparsely vegetated surface of the Mapimi Basin makes it an unusually good place to find meteorites. When a meteorite falls onto a dark forest floor, or into a river, or onto a mountain slope covered with vegetation, it is almost impossible to locate. When it falls onto a pale, flat, nearly featureless desert plain, it is visible from a distance, and when it falls onto a surface where soil erosion is low, it stays where it landed for a very long time. The geology of the Zone of Silence is therefore not a random collection of anomalies. It is the coherent product of a specific geological history. Ancient seabed, closed basin, mineral-rich sediments, flat and stable surface. Each of these features follows logically from what happened here over the last 100 million years. This does not make the place ordinary. It makes it extraordinary, in a way that is far more satisfying than any supernatural explanation, because it connects the zone to a history that is unimaginably vast, and to processes that are still ongoing today. Beneath the pale desert floor, in layers of rock that were once the floor of a tropical sea, minerals are still present, that have been there since before the first dinosaur went extinct. The magnetite that interferes with radio signals today was laid down in an ocean that no longer exists, in geological time that no human civilization was alive to witness. The Mapimi Basin is what geologists call an endorheic basin. It means a basin where water flows in, but does not flow out. There are no rivers draining the basin into the sea. When rain falls, it runs downhill into the basin floor and stays there until it evaporates. Over millions of years, this pattern of inflow without outflow has concentrated minerals in the basin sediments that would otherwise be carried away and dispersed by river systems. This is why the mineral concentrations in the Mapimi Basin are elevated compared to most desert soils. The iron, the uranium, the calcium, the magnesium, all of them have been accumulating in this enclosed geological container since the sea retreated. The basin is, in a sense, a slow and very long-running concentration experiment, run by nothing more than gravity and the absence of drainage. The Bolson de Mapimi, the larger depression of which the Zone of Silence is a part, covers tens of thousands of square kilometers. Its floor sits at roughly 900 meters above sea level. The mountains surrounding it rise to over 2,000 meters. Every mineral eroded from those mountains over millions of years has eventually found its way down to the basin floor and stayed. This is the deeper geological context for the zone. Not just ancient seafloor chemistry, but millions of years of concentration and accumulation in a closed system, producing a mineral-rich ground that speaks to every instrument sensitive enough to hear it. That is the kind of depth that deserves to be felt slowly, as you let your breathing become a little quieter and your body sink a little deeper into rest. The Zone of Silence has a reputation for meteorites. And this reputation, unlike some of the others attached to this place, is actually well-founded. In the 20th century alone, at least 3 significant meteorite falls were documented in or very near the Zone of Silence. 2 of them fell on the same ranch, separated by 16 years. The third was one of the most scientifically significant meteorites ever recovered in the Western Hemisphere. The first 2 falls, in 1938 and 1954, landed on a ranch near the edge of the desert. The owners reported hot rocks falling from the sky on both occasions. This is a standard description of meteorite impacts. Meteorites arrive fast enough to heat their surfaces dramatically, and they retain that heat for a time after landing. The third fall happened on February 8, 1969, at 1 in the morning. The event was visible across hundreds of kilometers. People in towns and ranches throughout the region saw the sky turn bright as day. For several seconds, windows shook. A sound like continuous thunder rolled across the landscape. A meteorite had entered the atmosphere, broken apart, and scattered thousands of fragments across an area in the Allende Valley, just west of the zone. It was heard as far away as Texas. The Allende meteorite, as it became known, was not just any meteorite. It was a carbonaceous chondrite, one of the oldest and most scientifically valuable types of meteorite known. Carbonaceous chondrites are pieces of the early solar system, formed before the planets existed, containing material that has been largely unchanged since the solar system was less than 5 million years old. The Allende fragments contained calcium-aluminum inclusions that were the oldest solid material ever dated from the solar system. Scientists from universities around the world came to collect fragments. It became one of the most studied meteorites in history. So the meteorites in and around the Zone of Silence are real. The falls have been documented. The rocks have been collected and analyzed. But what about the claim that the zone attracts more meteorites than other places? The popular version of the story suggests something is pulling them in, that the magnetic properties of the ground are drawing iron-rich rocks from space toward this particular patch of desert, like a magnet drawing iron filings across a table. Here is where the science becomes more careful. It is true that many meteorites are rich in iron. It is true that iron responds to magnetic fields. But the distances involved are enormous. A magnetic field that could attract a meteorite from the upper atmosphere would need to be incomprehensibly powerful, many orders of magnitude stronger than any magnetic anomaly measured in the zone. The Earth's own magnetic field is vastly weaker than would be needed to deflect an incoming meteorite by the hundreds of kilometers required to redirect one toward a specific 50-kilometer patch of desert. Physics does not support this mechanism. The more straightforward explanation is that the zone of silence and the surrounding Mapimi Basin is a genuinely excellent place to find and preserve meteorites. The flat, light-colored surface makes them visually conspicuous. The dry climate limits the weathering and erosion that would destroy or bury them. The closed basin geology means that fragments are not washed away by rivers. These are the same reasons why other desert regions, including the Atacama in South America and the dry valleys of Antarctica, are also considered prime meteorite hunting territory. They are not collecting more meteorites than fall elsewhere. They are simply much better at keeping the ones that fall. However, there is one genuinely puzzling aspect to the meteorite frequency in this region that scientists have not fully resolved. The concentration of documented falls does appear higher than would be expected by chance, even accounting for the favorable search conditions. Some researchers have proposed that the geological structure of the basin, combined with local atmospheric conditions related to its bowl-shaped topography, might create conditions that influence where fragments from a fragmenting bolide disperse. A bolide is a large, bright meteor that often explodes in the upper atmosphere. When it explodes, it scatters fragments across a wide area. The question is whether the topography of the Mapimi Basin could, in some circumstances, concentrate those fragments within its boundaries. This is a genuine open question, not a mystery requiring supernatural explanation, but a detailed scientific question about the relationship between incoming fragmentation events and local geography. The research continues. And for tonight, it is enough to hold the image, a stone older than the Earth's oceans, traveling through space for 4.5 billion years, crossing the solar system, entering the atmosphere at 50 kilometers per second, tearing a streak of fire across the night sky, and falling at last onto the pale floor of a Mexican desert, still warm from its passage, still carrying within it the oldest solid material in the solar system. The density of documented meteorite falls in the immediate area of the Mapimi Basin, and the repeated coincidence of them falling in the same general region, is statistically unusual, even accounting for the excellent search and preservation conditions. This has led some researchers to propose that the basin's topography, its bowl shape, and the local atmospheric conditions it produces might concentrate the debris from fragmenting bolides in ways that are not yet fully modeled. When a large meteor enters the atmosphere at a shallow angle and the fragments spread across a wide area. The pattern of that spread is determined by the meteor's speed, angle of entry, altitude of fragmentation, and local wind conditions at the time of the explosion. It is possible that the wind patterns associated with the Mapimi Basin, influenced by the surrounding mountains, and the temperature differential between the basin floor and the higher terrain, could in some circumstances direct fragments into the basin, rather than letting them disperse evenly. This is not a confirmed mechanism. It is a hypothesis that has been discussed, but not rigorously tested. The data required to test it, detailed records of meteorite fall locations combined with atmospheric modeling for each event, would be difficult to assemble for historical falls. Future falls, if documented with the right instrumentation, might eventually resolve the question. That is real, and it is extraordinary enough on its own. To understand how the Zone of Silence became famous, you need to know about a missile. On July 11, 1970, the United States Air Force launched a test rocket from the Green River Launch Complex in the state of Utah. The rocket was an Athena re-entry test vehicle. Its job was simple. It was to travel through the upper atmosphere, gather data on how vehicles behave when they re-enter the air from space, and come down in the White Sands Missile Range in New Mexico, where it could be collected and its instruments read. It did not do this. Instead, For reasons that were never fully and publicly explained, the rocket veered off course. Dramatically off course. It traveled not a few kilometers past its target, or a few dozen. It traveled approximately 650 kilometers beyond where it was supposed to land, crossing the United States border into Mexico, and came down in the Mapimi Desert, right in the middle of what would become known as the Zone of Silence. The rocket was carrying a radioactive payload. Specifically, it contained cobalt-57, a radioactive isotope used as a tracer in the atmospheric experiments the rocket was conducting. Cobalt-57 is not highly dangerous, but its presence made the recovery operation a formal matter, requiring coordination between the United States and Mexican governments. What happened next is important for understanding how the legend of the zone was born. The American military sent a substantial team to recover the rocket. They constructed a temporary airstrip in the desert. They negotiated with the Mexican government for access. They hired local workers. They set up dormitories, kitchens, and laboratories in the middle of nowhere. They used heavy equipment to excavate the impact site. They filled trucks with soil from the crash area, along with the rocket wreckage, and transported it all back across the border. Then they left, taking the equipment with them, and were largely silent about what had happened. The secrecy was not sinister. It was standard military protocol for a classified test vehicle accident. But in a remote desert region where very few things happened, the sudden arrival of dozens of American military personnel who refused to explain their presence was extraordinary. Local workers and ranchers watched the operation. They saw the Americans digging out a sand dune and hauling it away in trucks. They heard no explanation. The American government offered no public statement. Into this vacuum of explanation, stories flowed. The most persistent story, spread initially by a small group of local entrepreneurs who called themselves Zonros, was that the missile had been pulled off course by the unusual magnetic properties of the zone. The strange magnetic waves in the desert, the story went, were so powerful that they had reached up and seized the rocket, redirecting it hundreds of kilometers from its intended path. This is a compelling story. It is also physically impossible. The magnetic anomalies in the Mapimi Basin, while real and measurable, are local features. They are strong enough to affect a compass needle held within centimeters of certain rocks. They are not strong enough to deflect a ballistic rocket, traveling at several kilometers per second in the upper atmosphere. The forces required would be orders of magnitude beyond anything measured in the zone. The missile went off course because of a malfunction in its guidance system, the same explanation that the investigation concluded, though the details were classified. But the story of the Zone of Silence was already too good to let physics correct it. The Zonros began guiding tourists to the area. They pointed to compass needles that did indeed spin when held near certain rocks on the ground, which is true, because those rocks are rich in magnetite. They claimed radios would not work, which was sometimes true in certain spots, and often not true at all. They told stories of alien visitors and mutant animals and dimensional portals. And the tourists came. It is worth noting here that the scientist Andrea Kaus, who conducted doctoral research in the Mapimi Biosphere Reserve in the 1980s and 1990s, wrote very clearly that neither she nor any of the researchers she spoke to had any trouble with radios or compasses while working in the reserve. The signal failures reported by the Zonros were inconsistent, localized, and often simply not present. But absence of evidence is hard to sell to people who have traveled a long way to experience a mystery. And so the myth grew, while the real and genuinely interesting geology of the place received far less attention. After the recovery operation was complete and the Americans had left, a second incident brought a spacecraft back to the same desert. Several years after the Athena missile crash, an upper stage from one of the Saturn V rockets used in the Apollo program, having completed its mission and decayed from orbit, broke apart in the upper atmosphere and scattered debris across northern Mexico, including in and around the Mapimi Basin. Once again, American recovery teams came to the desert. This second incident reinforced the impression that American aerospace hardware had a strange affinity for this particular patch of ground. The statistical improbability of two separate pieces of American space hardware falling in the same remote desert, separated by a few years, was striking. To the zoneros and the growing population of tourists visiting the zone, this was further evidence that something in the desert was attracting objects from above. From a purely probabilistic standpoint, the coincidence is genuinely unusual. But the mathematics of unusual coincidences is tricky. With dozens of missiles and spacecraft components making uncontrolled re-entries over the decades of the space program, and with northern Mexico being a reasonably large target area below typical test vehicle trajectories from western United States launch sites, the probability of at least one impact in the region was not as low as it might seem. Two impacts, though striking, fall within the range of events that can occur by chance. The Zone of Silence is in some ways a story about how a place becomes a story, about how secrecy creates rumors, about how local economic incentives can transform a genuine scientific curiosity into a tourist attraction built on embellishment, and about how the real story, which is fascinating enough, gets drowned out by a louder and simpler narrative. But the real story is still there, underneath. In the rocks, in the mineral deposits, in the ancient seabed layers, in the meteorites, in the complicated truth of what radio waves actually do in this particular piece of ground. Let us spend some time with magnetite. Magnetite is a mineral. It forms as a black or dark brown crystal, heavy for its size, and strongly magnetic. In fact, magnetite is the most naturally magnetic mineral found in the Earth's crust. A piece of magnetite, even a small one, will attract a compass needle from several centimeters away. A compass held near a large magnetite-rich rock can spin freely, unable to find north, because the local magnetic field of the rock overwhelms the weaker and more distant signal of the Earth's own magnetic field. Magnetite is common in the Earth's crust. It forms in igneous rocks when magma cools. It forms in metamorphic rocks when other minerals are changed by heat and pressure. It forms in sedimentary deposits when iron from the surrounding environment is concentrated by chemical processes. And, importantly for the Zone of Silence, it is a major component of many meteorites, particularly the iron-rich stony iron meteorites that have been falling on this desert for a very long time. In a place with a high concentration of magnetite-bearing rocks and soils, the local magnetic environment is genuinely unusual. The Earth's own magnetic field is remarkably consistent across large distances. It varies slowly and predictably with latitude, but a region where the ground contains dense pockets of natural magnetite will have local magnetic anomalies, places where the field measured by an instrument is significantly different from what you would expect based on the Earth's global field alone. These local anomalies are real in the Zone of Silence. They have been measured by geologists working in the Mapimi Basin. They are not evenly distributed across the zone. They are concentrated in specific areas, particularly in places where meteorite fragments have been found, or where the sedimentary geology brings mineral-rich layers close to the surface. When you hold a compass near one of these anomaly points, the needle behaves strangely. It may point in the wrong direction. It may oscillate slowly back and forth. It may swing away from north and toward the local magnetic source. To a visitor unfamiliar with mineral magnetism, this can feel deeply disorienting. The compass, a tool you trust to tell you where you are, is lying to you. Your sense of direction becomes unreliable. Now combine that with the signal interference effects of dense magnetite on radio waves. A radio trying to receive a distant signal in an area where the ground contains substantial iron oxide minerals will experience increased interference. The signal, which normally travels easily through air, encounters a medium that absorbs and scatters electromagnetic energy. The result is static, dropout, silence. These effects are real. They are documented. They are the product of well-understood physics, but they are also inconsistent. The magnetite deposits are not uniformly distributed. Move 50 meters in one direction, and the ground composition changes. The anomaly disappears. The compass works again. The radio signal returns. This is why the scientists who have worked in the reserve consistently report that their instruments functioned normally most of the time. They were not always standing in the right spot. The zone of silence, understood this way, is not a place where all signals die. It is a place where certain signals die in certain spots, unpredictably, in a way that is directly traceable to local mineral concentrations. It is an electromagnetic patchwork. Some patches are quiet. Some are noisy. Some are magnetically bizarre. Most are perfectly ordinary. The map of those patches corresponds to the map of the geological anomalies beneath the surface. And the map of those anomalies is itself a map of geological history, of ancient ocean chemistry, of meteorite falls, of mineral accumulation over millions of years. Magnetite retains a magnetic signature from the time it was formed. When iron-rich rock cools from a molten state, or when minerals precipitate from a solution, the magnetic domains within the forming magnetite align with whatever magnetic field is present at that moment. The rock then carries that alignment as a permanent record, a magnetic memory of the field it formed in. This phenomenon is called paleomagnetism. Scientists use it to study the history of the Earth's magnetic field, which has reversed direction many times over geological history. Rocks formed at different times carried different magnetic signatures, and by reading those signatures, scientists can reconstruct where the rock formed relative to the magnetic poles and when. The magnetite in the zone of silence carries paleomagnetic signatures from various times in its geological history, including from the ancient seafloor period, from subsequent volcanic and metamorphic events, and from the meteorites themselves, which carry the magnetic signatures of their formation environments in the early solar system. When you hold a compass over certain rocks in the zone and watch the needle swing away from north, you are not just seeing the effect of local mineral magnetism. You are reading a record of the Earth's magnetic history, encoded in crystal structures that were laid down when the ground here was the floor of a warm ocean, and the continents were in different positions. The needle is not confused. It is reading a very old message. There is one more dimension worth understanding before we leave magnetite behind. The distribution of magnetite in the zone is not random. It follows the geological structure of the basin, where the ancient seafloor sediments are thickest, where meteorite fragments have accumulated over centuries, where volcanic intrusions brought iron-rich material close to the surface. That is where the anomalies are strongest. The electromagnetic patchwork of the zone is, in this sense, a direct printout of the basin's geological history. A map of what happened here, written in the language of magnetic field strength, readable by any instrument sensitive enough to listen. This is what makes the zone genuinely extraordinary, not as a place of supernatural mystery, but as a place where the deep past is still actively present. Most landscapes have been reshaped enough by erosion, by human activity, by the slow grinding of geological time, that their history is buried and invisible. The Mapimi Basin, with its dry climate and its closed drainage, has preserved its record unusually well. The minerals are still where they landed. The meteorite fragments are still near the surface. The paleomagnetic signatures are still intact. The ground here is, in a real and measurable sense, still telling the same story it has been telling for millions of years. Let that settle. The ground speaking in the language of magnetism. The rocks remembering a sea that has been gone for 65 million years. The compass needle swinging, not toward alien technology, but toward a piece of the ancient seafloor that happens to contain more iron than its neighbors. The zone of silence is not only a geological story, It is also a biological one. The Mapimi Biosphere Reserve, which covers roughly 342,000 hectares of desert, is one of the most ecologically interesting protected areas in North America. It was declared a biosphere reserve in 1979, partly to protect its unusual combination of geological and biological features. And the biology here is genuinely remarkable, quite apart from any electromagnetic anomalies. The Chihuahuan Desert is the largest hot desert in North America. It stretches from northern Mexico into parts of Texas, New Mexico, and Arizona. Its climate is harsh and extreme. Summer temperatures routinely exceed 40 degrees Celsius. Winter nights can drop well below freezing. Annual rainfall is low and unpredictable. The soil in most areas is thin, dry, and mineral-rich. And yet more than 400 plant species have been documented within the Mapimi Reserve alone. Many of them are endemic, meaning they are found nowhere else on Earth. The reserve contains species of cacti adapted to survive years without significant rain. There is a species of prickly pear cactus that turns a striking shade of purple during dry spells, which is how it sheds excess solar energy and reduces water loss. This adaptation is specific to the local conditions and has not been observed in closely related species living in less extreme environments. The Bolson tortoise is perhaps the most famous animal resident of the zone. This is a large tortoise, one of the biggest land tortoises in North America, with a shell that can reach 60 centimeters in length. It is adapted to the desert's extreme temperatures, spending the hottest parts of the day in burrows it excavates in the soil. It feeds on plants and can survive on the moisture content of its food alone during prolonged dry periods. The Bolson tortoise population in the Mapimi Basin has an unusual feature that attracted scientific attention. Some individuals show a pattern variant in the scales of their legs, an irregular arrangement that differs from the standard pattern seen in most of the population. Early observers, influenced by the zone's reputation for strangeness, claimed this was evidence of mutation caused by elevated radiation from the uranium deposits in the soil. Later scientific analysis showed it to be a normal pattern variant, a natural variation within the genetic diversity of the population, with no connection to radiation exposure. This is a pattern you will notice in the zone of silence. Real, interesting biological features exist here, and they are consistently misattributed to supernatural or radiation-based causes by visitors who arrive expecting the extraordinary. The extraordinary is already here in the actual biology. It does not need embellishment. The desert also supports 200 species of birds, including the golden eagle, which nests in the mountainous areas surrounding the basin. Dozens of species of reptiles, amphibians, and small mammals have been documented. The food web of the Chihuahuan Desert is intricate and well studied, connecting plants adapted to aridity with insects, reptiles, rodents, and the predators that depend on them. The research station built in the Mapimi Reserve in 1978 has produced decades of biological research on this ecosystem. Scientists studying plant-water relations, tortoise population dynamics, bird migration patterns, and desert soil ecology have worked here. The station is called Laboratorio del Desierto, the Desert Laboratory. Its scientists, unlike the zonos, have generally had no trouble with their radios. Because the zone of silence sits on ancient seafloor sediments, the ground here contains fossils of marine organisms from the Cretaceous period. Ammonites, the coiled shell creatures that were among the most successful marine animals of their time, have been found here. Their flat spiral shapes, compressed by millions of years of geological pressure, emerge from the pale rock like messages from an ocean that has not existed for 65 million years. This is one of the genuinely strange things about walking in the zone. You are walking in a desert. The air is dry. The temperature is extreme. Cacti surround you. And yet if you stop and look carefully at the rocks beneath your feet, you may find the outline of a creature that spent its entire life underwater in a warm tropical sea when the largest animals on land were dinosaurs. The research station has also been important for studying desert hydrology. The endorheic nature of the Mapimi Basin makes it an ideal natural laboratory for understanding how water moves through desert soils, how mineral concentrations change over time as water evaporates, and how desert plants have evolved to extract moisture from environments where rain may not fall for years at a time. Desert hydrology matters beyond the zone. As climate patterns change and more regions face extended drought conditions, the adaptations of desert plants and the water management strategies of desert soils become increasingly important. The research conducted in the Mapimi Basin contributes to a broader understanding of how life survives in the driest conditions on Earth. The Zone of Silence is a laboratory. It has always been a laboratory. The research conducted there by scientists who have no interest in the alien stories, who find the geology and biology entirely absorbing on their own terms, represents decades of accumulated knowledge about a unique environment. That knowledge is the real treasure of the zone. Not the compass anomalies, not the meteorites, not the strangers. The understanding of how life and rock and mineral and climate interact over geological time in a closed desert basin. The Zone of Silence is full of this kind of wonder. The kind that gets quieter attention than alien visitors, but that stays in the mind longer. What the biology of the zone teaches us, most fundamentally, is that the extraordinary does not need to be supernatural to be worth paying attention to. A cactus that turns purple to survive. A tortoise that has outlasted every geological change since the Pleistocene. A golden eagle soaring over land that was once the floor of a warm sea. An ammonite fossil pressed into the rock beneath your boots. A creature that swam through the water above this exact spot 65 million years before you were born. These are real wonders. They were produced by millions of years of evolution in a specific and demanding environment. They do not require embellishment. They do not require alien explanations. They require only attention and a willingness to let the ordinary scale of things become visible. The ordinary scale of things in the Zone of Silence happens to be extraordinary. That is the nature of deep time. When you understand how long the Earth has been at work, ordinary geology becomes astonishing. Ordinary biology becomes miraculous. And a desert that was once a sea becomes the most quietly remarkable place you have ever stood. There is a question underneath the Zone of Silence that is not a geological question. It is a question about how human beings relate to places that feel strange. Why do some places collect myths, the way the Mapimi Basin collects meteorites? Part of the answer is physical. The Zone of Silence has real features that are genuinely disorienting. A compass that spins near certain rocks is a compass that is telling you it does not know where north is. That is an unsettling experience for a person who depends on direction. A radio that goes silent in a specific spot, then works again 20 meters away, creates an impression that something invisible and selective is operating in that place. Something is choosing to interfere here and not there. Something with intention. Human minds are exceptionally well adapted to finding patterns and inferring intention. This is one of the most useful cognitive abilities we have. It allows us to detect threats, read social situations, and plan for the future. But it also means that when we encounter genuinely unexplained phenomena, our first and most compelling response is to reach for an intentional explanation. Something is doing this. Something wants this. Something is here. In the Zone of Silence, the intentional explanation available in the local culture was specific. Aliens, electromagnetic vortexes, dimensional portals. These explanations were shaped and promoted by the Zonros, who had a genuine economic interest in maintaining the zone's reputation for mystery. Tourism brought income to a very poor and very remote region. the more mysterious the zone, the more people would come. This is not a cynical observation. It is a rational response to economic incentives in a part of Mexico where other income was scarce. The ranchers and guides who built the tourist trade around the zone were doing what people do. They were using what they had. But the myth-making had consequences. The most significant was the way it overwhelmed the real science. The Mapimi Reserve contains genuinely important geological and biological research. The ancient seabed geology is of real scientific interest. The endemic species are worth protecting and studying. The meteorite record has produced material of extraordinary scientific value. All of this tends to be ignored in accounts of the zone that focus on aliens and compasses. There is also the parallel between the Zone of Silence and other places that have attracted similar myths. The Bermuda Triangle is the most famous comparison. The zone shares its latitude line, very roughly, with both the Bermuda Triangle and the Egyptian pyramids, a fact the zoneros point to as evidence of a global pattern. In reality, the 27th parallel is simply a line of latitude. It circles the Earth and passes through many places, most of which have no unusual properties at all. The alignment of three anomalous-seeming places on the same latitude is not statistically significant when you consider how many locations on that latitude have been examined and found to be entirely ordinary. What these places share is not a physical connection. What they share is a human one. They are all places where real, confusing events have been reported, where explanations were incomplete or suppressed, and where the economic or cultural incentives for maintaining a reputation for mystery were sufficient to sustain the myth against the slow pressure of investigation. We find mystery beautiful. We find it exciting. A place that defies easy explanation appeals to something deep in us, something that was perhaps very useful for our ancestors, but that, in a modern context, can lead us away from understanding rather than toward it. The Zone of Silence is more interesting, in almost every measurable way, as a geological and biological phenomenon than as a home for alien visitors. But it is the alien visitors that fill the tourist hotels in Ceballos. The Bermuda Triangle became famous in the 1960s and 70s through a series of popular books that compiled unusual disappearances of ships and aircraft and attributed them to mysterious forces. Later analysis by skeptical researchers showed that the rate of disappearances in the Bermuda Triangle was not actually higher than in other heavily traveled ocean regions of comparable size. The triangle had attracted attention partly because of its dramatic geography, partly because of the high volume of traffic passing through it, and partly because certain writers had selectively compiled the dramatic cases while omitting the ordinary ones. The Zone of Silence follows a similar pattern. The radio anomalies are real, but inconsistent. The meteorites are real, but not miraculous. The compass effects are real, but physically explainable. The missiles were accidents, not attractions. And the strangers were people, not aliens. What made the zone famous was not the phenomena. It was the story told about the phenomena. And that story was shaped by specific people, with specific interests, in a specific cultural moment, when UFO mythology was flourishing across North America. Wonder is valuable. The desire to find meaning and mystery in the world is part of what makes human beings interesting and resilient. But wonder works best when it is honest about what it is, when it follows the evidence rather than preceding it, when it holds the question open rather than supplying a ready-made answer. The Zone of Silence, understood scientifically, is genuinely wonderful. It is a piece of deep geological history that you can touch. It is a biological reserve full of creatures adapted to extreme conditions. It is a site of meteorite falls that connect this desert to the earliest moments of the solar system. It is an electromagnetic landscape shaped by minerals laid down in an ocean 65 million years gone. That is enough. More than enough. No aliens required. The science is here for anyone willing to look. And it is quieter than the stories, and stranger, and more deeply connected to what actually happened in this place over 100 million years of time. And perhaps that is the final thing worth saying about the myths of the zone. They are not enemies of the science. They are evidence of the same impulse that drives science forward. The impulse to look at something unusual and ask why. The difference is only in the method. The zoner looks at the spinning compass needle and reaches for the nearest available story. The geologist looks at the same needle and reaches for the nearest available measurement. Both are responding to something real. Both are trying to make sense of a world that contains more strangeness than everyday life usually reveals. The science just happens to be better at finding the strangeness that is actually there, rather than importing strangeness from elsewhere. And the strangeness that is actually there, in the Mapimi Basin, in the ancient minerals, and the meteorite record, and the sealed drainage, and the fossils of a vanished sea, is more than sufficient. It does not need supplementing. One of the persistent stories about the zone of silence involves mutation. Plants with unusual forms, animals with deformities, life that has been somehow changed by something in the environment. The implication is that the uranium deposits in the zone are releasing radiation at levels high enough to alter the DNA of living organisms, producing visible changes in the creatures that live here. This is a testable claim, and when it has been tested, the results are clear. Uranium is a radioactive element. When uranium atoms decay, they release particles and energy that can, at high doses, damage DNA. This is the basis for radiation sickness and for the increased cancer risk associated with exposure to high-intensity radiation sources. Nuclear power plants, nuclear weapons, and improperly handled medical radioactive materials are examples of sources capable of delivering harmful radiation doses. Background radiation from natural uranium deposits in rock and soil is different. Natural uranium is present at low concentrations in almost all rocks and soils everywhere on Earth. The average concentration of uranium in the Earth's crust is about 2 to 3 parts per million by weight. Elevated uranium concentrations exist in certain geological formations, including some sedimentary deposits like those in the Mapimi Basin. These elevated concentrations produce locally higher background radiation than would be found in most areas. But how much higher? Measurements taken in the Mapimi Reserve by environmental researchers have found background radiation levels in the zone that are higher than average, but within the range of natural background radiation found in many parts of the world, including parts of Brazil, India, Iran, and Scandinavia, where granite-rich soils contain elevated thorium and uranium concentrations. People live in these areas for entire lifetimes, with no detectable increase in health problems attributable to the background radiation. The levels in the zone, while elevated relative to average desert soils, are not high enough to cause the kind of DNA damage that produces visible mutations in animals. The specific claims about mutant animals in the zone have been investigated directly. The triangular pattern variation in the scales of some Bolson tortoises, which attracted early attention, was studied by biologists who confirmed it is a naturally occurring genetic variant, present in a small percentage of the tortoise population throughout its range, not just in the zone. It has nothing to do with radiation. It is the kind of genetic variation that exists in all populations. Cacti that turn purple during dry spells do so through a physiological process involving pigments called anthocyanins, which are produced in response to drought stress and high light levels. This is a well-documented adaptation found in many plant species across the world. It is not a mutation. It is a stress response. The claims about mutant plants and animals in the zone are, in the language of science, not supported by evidence. They are the result of observers who arrived expecting strangeness, found the ordinary, remarkable seeming strangeness of desert life, and interpreted it through the framework of the zone's reputation. This matters because it illustrates something that applies far beyond the zone of silence. Expectation shapes observation. When we believe something extraordinary is present, we see ordinary things as extraordinary. The purple cactus is not a mutant cactus. It is a very well-adapted cactus, doing what it evolved to do. But if you arrive in the zone looking for evidence of radiation effects, a purple cactus looks like a mutation. Science has a method for dealing with this. It is called controlled observation. It involves measuring things systematically, under conditions designed to prevent expectation from biasing the result. When the zone's biology was studied this way, the mutant animals did not appear in the data. The adaptations appeared instead. Beautiful, specific, evolved, and entirely natural. Uranium is a heavy element. It was not created in the Big Bang. It was created in the violent deaths of massive stars, in the supernova explosions that scatter newly synthesized heavy elements across the galaxy. The uranium in the ground beneath the zone of silence was created in a stellar explosion that happened before the solar system existed. It was incorporated into the dust cloud from which the Sun and Earth formed, and it has been slowly decaying inside the Earth ever since. Uranium decays over immense timescales. The most common isotope of uranium has a half-life of 4.5 billion years, which is approximately the age of the Earth. A gram of uranium that existed when the Earth formed has lost only half of its atoms to radioactive decay over the entire history of the planet. The rest is still here, still decaying at the same slow rate. When uranium decays, it produces a series of daughter products. These include radon, a radioactive gas that can seep through soil and accumulate in enclosed spaces. Radon is a genuine health concern in certain geological environments, and its concentration in the Mapimi Basin has been measured. The levels found are not dramatically higher than those found in many inhabited areas around the world, where granite or uranium-bearing sedimentary rocks are common. They are within the range of natural variation. The uranium in the zone of silence is old beyond imagining. It came from a dead star. It has been in the ground since before the first animal drew breath on Earth. It is decaying at the same rate. It has always decayed, quietly, in the dark, with complete indifference to the stories being told about it, above the surface. No species found in the zone of silence is considered a mutant form of a related species from elsewhere. The endemic species here are genuinely distinct evolutionary lineages that developed in isolation over long periods of time. Their distinctiveness is the product of geography and time, not radiation. The desert acted as a barrier that separated these populations from related populations elsewhere, allowing them to evolve independently until they became their own species. That is the normal mechanism of evolution in geographically isolated environments. It requires no unusual radiation, no alien interference, no electromagnetic anomaly, just time and isolation, and the slow pressure of natural selection. The zone is still extraordinary, just not in the way the stories say. There is one story from the zone of silence that is different from the others. It does not involve instruments or missiles or radiation. It involves people. Over several decades, multiple ranchers and visitors in the Mapimi Basin reported encounters with the same three strangers. 2 men and a woman, all three described as blonde, an unusual appearance in a region where most residents are of Mexican descent. They are described as tall, well-dressed in a way that is unsuitable for desert travel, speaking perfect Spanish with no accent anyone can identify. They appear at remote ranches, far from any road, under circumstances that make their presence inexplicable. They ask for nothing except water. They fill containers from the ranch well, They thank the residents politely and walk away into the desert. They leave no footprints, and they have never been photographed. This story has been told consistently enough, by enough independent witnesses across a long enough period of time, that it has become one of the most cited elements of the zone's mythology. The three blonde strangers. The Zoneros say they are aliens. Some visitors interpret them as interdimensional travelers. Others suggest they may be time travelers. What can science say about this? Not much directly. Science works with evidence. The strangers have not been photographed. No physical evidence of their presence has been collected and verified. The reports are eyewitness accounts from people who may or may not be reliable narrators, in a context where expectation and reputation make unusual interpretations more likely. What psychology and sociology can say is more useful. Reports of unusual strangers appearing in remote areas, asking for mundane things like water, and then disappearing, are found in many cultures across many centuries. They are a category of folklore that appears in stories from Europe, from Asia, from the Americas, from Africa. In some traditions, these figures are angels. In others, they are spirits. In others, they are demons. In the zone of silence, in the late 20th and early 21st centuries, they are aliens. The specific details change with the cultural context. The blonde hair and tall stature of the zone strangers match the popular imagination of Nordic-type extraterrestrials, common in 20th century UFO literature. The category of the story, the mysterious visitor who appears from nowhere, asks for something simple, and vanishes without explanation, is ancient and universal. This does not mean the witnesses were lying. People report experiences that they genuinely had, but memory is reconstructive. Expectations shape what we see and how we remember it. A genuine encounter with unusual-looking strangers in a remote area, seen from a distance, imperfectly remembered, recalled in a context where the zone's reputation makes unusual explanations available, can produce a story that has the structure of the blonde stranger accounts, without requiring anything beyond ordinary human psychology. The Mapimi Basin is remote. The nearest town of any size is Sibalos, roughly 40 kilometers from the zone's center. Beyond Sibalos, the nearest cities are hours away by road. The people who live and work in the desert, the ranchers and their families, exist in a social world that is isolated enough that unusual encounters are interpreted in the context of that isolation. In such environments, strangers are inherently significant. The arrival of unfamiliar people at a remote ranch is an event. It is remembered. It is discussed. The details are reviewed, and the meaning is debated. When the stranger is described as blonde, or as speaking with an unusual accent, or as wearing inappropriate clothing for the environment, those unusual details are weighted heavily because they are so inconsistent with the expected profile of the people who normally pass through. Over time, as the story is retold, the most unusual and striking details are emphasized. The ordinary details are forgotten. The encounter becomes cleaner and stranger in each retelling. The strangers become taller. Their clothing becomes more inexplicably unsuitable. Their departure becomes more mysterious. By the time the story has been told a dozen times, it has the structure of an encounter with something genuinely not human. This is not a criticism of the people telling the story. It is a description of how memory and social transmission work in all human cultures. Stories change as they travel. The unusual details survive and grow. The ordinary context falls away. Water is the fundamental resource of the desert. Every living thing in the Chihuahuan Desert, from the purple cactus to the Bolson tortoise to the rancher's family, is organized around water. Where it comes from, how to find it, how to keep it, how to survive when it is not available. A stranger arriving at a remote ranch in the middle of a desert and asking for water is asking for the most essential and most locally significant thing there is. In a desert, the sharing of water is a gesture of profound hospitality and human connection. Whatever the strangers were, the stories about them are stories about the desert's relationship with water, about the way the desert makes water central to every encounter, every survival calculation, every act of kindness. The strangers who ask for water and then disappear are, in this sense, metaphors for the desert itself. It takes. It moves. It leaves no footprints. The strangers are the most human part of the zone of silence. They represent the way that places with unusual reputations attract unusual interpretations of ordinary events, and they serve as a reminder that the most interesting mysteries are not always in the ground. Sometimes they are in the space between what we see and what we believe. And in the end, perhaps the three strangers are the zone's most honest metaphor. They arrive without explanation. They take what they need. They leave nothing behind that can be measured or verified. They are remembered differently by everyone who encounters them. They grow stranger with each retelling, and no one can prove with certainty what they were. That is also the story of the zone itself, a place that arrived in the popular imagination without adequate explanation, that has been used by tourists and writers and television producers to fill a need for mystery. That has left behind a reputation far stranger than the reality. That is remembered differently by the scientist and the zonero and the rancher and the visitor, and that no one can fully explain, not because the physics are mysterious, but because places accumulate meaning the way deserts accumulate minerals, slowly, in layers, over time, with no single event responsible for what is finally there. We have come a long way tonight, across the pale desert of the Mapimi Basin. We began with a radio signal, and the physics of how electromagnetic energy travels through air, and what stops it. We went back 100 million years to walk the floor of an ancient sea, and we understood how the mineral content of that long-gone ocean bottom still shapes the electromagnetic environment of a desert that has forgotten it was ever underwater. We followed meteorites. We understood why so many of them fell here, and why the ones that did fall left so much iron in the soil, and why that iron speaks to every compass and every radio that passes through certain spots in the zone. We saw that the frequency of meteorite falls here is real, and that it has a geography-based explanation that is more interesting than the alternative. We followed the missile. We understood how a guidance malfunction became a legend, how American secrecy in a remote Mexican desert created a vacuum that local mythmakers filled with a story that served everyone's interests. We saw how a compass needle that points to a rock instead of north becomes evidence of a vortex when the right story is already in the air. We spent time with magnetite. We understood what it is, where it came from, and what it does to electromagnetic signals. We saw that the zone is not a uniform dead zone for radio signals, but a variable and patchy landscape of interference, traceable to specific mineral deposits in specific locations. We walked through the biology of the Chihuahuan Desert and found wonders that do not need embellishment. Cacti turning purple to survive, tortoises living on the floor of an ancient sea, golden eagles crossing the sky above rocks that have been here since the Cretaceous. We thought about why places like this collect myths, and what that tells us about human psychology, about how expectation shapes observation, about how economic incentives maintain legends against the slow pressure of evidence. We sat with the strangers who asked for water, and we found in them not evidence of alien visitors, but evidence of something more interesting. The way human beings reach for meaning in places that feel different, the way ancient story patterns reassert themselves in new costumes, the way a remote desert can become a mirror for whatever a culture is most afraid of or most hungry for. And now we are at the end. What does the zone of silence teach us? It teaches us that real places are always more interesting than their myths, because real places have real histories, And real histories are stranger and more complex, and more connected to the vast machinery of geological and biological time than any story about extraterrestrials or dimensional portals could be. The Zone of Silence is a piece of ancient seafloor, compressed and baked and lifted above the waves by tectonic forces over tens of millions of years, sitting now in one of the most arid climates on Earth, its mineral-rich rocks interfering with the radio waves of a civilization that appeared on this planet a geological instant ago, still falling rocks from space that have been traveling toward it since before the solar system had planets. That is the Zone of Silence. Not a contradiction, not a violation of the laws of nature, not a doorway to another dimension, but a place where the normal laws of physics, applied to an unusual and specific geological history, produce effects that feel strange to people who have forgotten that the Earth is 4.5 billion years old and that the ground beneath their feet has a story most of us have never been asked to read. The compass needle spins because of iron in the rock. The iron in the rock came from space, from stars that exploded before the sun existed and scattered their cores across the galaxy. The galaxy carried that iron through 4 billion years, to the point where it fell onto a desert in Mexico. And now it is pointing your compass in the wrong direction, while you try to figure out where you are. That is the silence of the zone. Not the absence of signals, but the presence of something so much older and stranger than we usually remember, speaking in the language of magnetism and geology and cosmic time, asking only to be heard. To say a place is geologically significant is to say that it holds a record, that what happened here over millions and hundreds of millions of years left marks that can still be read, that the story of deep time is still legible in the rocks if you know how to look. The Mapimi Basin is geologically significant in multiple overlapping ways. The ancient seafloor sediments preserve a record of the Cretaceous Ocean. The Enderhaek Basin structure preserves a record of millions of years of mineral accumulation. The meteorite fragments preserve a record of the earliest materials of the solar system. The paleomagnetic signatures in the magnetite preserve a record of the Earth's magnetic field at the time those crystals formed. Every rock you step on in the zone is a record. Every layer of sediment beneath the pale surface is a record. Every magnetite crystal pointing its tiny internal magnet in the direction it has been pointing since before humans existed is a record. The Zone of Silence does not silence these records. It is made of them. Now, let all of that become soft. Let the desert settle around you, pale and still, under a sky full of stars that are older than the ocean that was once here. Let the compass needle rest. Let the radio static fade into a frequency you cannot quite name, but that feels somehow like being very small and very present and very connected to something ancient and continuous and real. The desert is patient. The rocks are patient. The iron in the ground has been waiting for a long time. And now it is your turn to rest. If this journey left something in you, please consider liking or subscribing. It helps other curious minds find their way here. For now, let your body become heavy. Let your breathing slow to its own quiet rhythm. Let the pale desert dissolve into something warmer and softer, carrying you forward into sleep. Good night.